in it. And previously, I have worked with Dr. Taib Imran, and I am around attached with him around 7 to 8 years. He was basically my master supervisor. So my basic research field revolve around optical instrumentation and laser development, and mostly I'm interested in doing like optical characterization of different material using some advanced setup as well. And in the besides that, I also have published a lot of things with Dr. Taib Imran. And basically my specialization is basically I'm very much good in optical simulation using ZMAX. So that is a short introduction of mine. And I was for a few time I was just little bit busy with my PhD work, so I was not able to attend the previous meetings. So hope so now we will continue and do some great work together. Let's hope for the best.
Okay, so David, you can see on the back side of Mudassar, you can see the optical table.
Yes, I can see
Optical
the
table
optical
and the
table.
setup, BLS setup actually. It's a complicated kind of thing. You may not understand this thing actually. But Mudassar, David actually is more like an engineer.
Okay.
So David, you can tell about yourself. I mean, again, a bit, so he to know.
Yes, I am a communication and electronic engineer, but when I was studying at my university, most of my professor come from a doctorate degree in optics. They graduate from my university like electronic engineer, but then they do a master in electronic engineering, and then they do the PhD in an optics institute here at Mexico, and they do thesis like working in nonlinear optics like solitones, dark solitones, bright solitones. Also, they use set scan techniques, eye technique when for nonlinear properties. They also go to SPY and Optical Society Congress, and also for they do sensors. One of my professor, Dr. Ojeda, they do did an image sensor that capture the frontal plane and the back plane at the same time. They mix together. They have specialized in Fourier optics. Okay. And when I was working at my university, I do an optical spectrometer. I use a webcam and I remove the infrared filter and then put in a software, Teremino, that is a company from Italy that give you the software, and then you can put the camera and get work in the spectrometer. Also, I do a solar collector for ecological source of lighting, and you got a parabola collector with Fresnel lenses in the top of the roof, and then collect by plastic optic fiber, and then with a diffuser, and also we put infrared and UV filters, and then you can light inside from an office or a house. And also I participate in the Nonlinear Optics Congress at Hawaii, USA, and I visit the Max Planck Institute for the Science of Light in Erlangen, Germany. This for a Sigma International School on Laser 2015. Okay. And also I participate in the.
You are optical engineer.
Not, but I like a lot optical.
Okay.
He mentioned that communication.
Yeah. Okay. Communication.
Or like communication. So actually, Mudassar, he did the same thing about the spectrometer. What we were trying actually, if you remember in ComSat, in the ComSat actually, that Noor's thesis.
Yeah.
So he built that kind of using a webcam, and they have a kind of write-up, I mean, kind of report on it, which I have seen.
We basically use LabVIEW to take the spectrum from the images. Usually we take the spectrometer right directly, like we take the images using LabVIEW, we just extract the spectra, which was a quite good try for a spectrometer. But initially we have done this kind of thing.
Mhm. Yeah, but I think they use, David, you people use the Python or for the data acquisition?
Okay. For the data acquisition, we use the Teremino software. This is a free open source
Okay.
software. But yeah, they can use LabVIEW
Mhm. Yeah, in our case, we use it.
or MATLAB also.
Yeah, at level is
Okay.
also possible. Mhm. Okay, so probably David, you can start your idea. See.
Oh, okay. Okay, I'm going to share. Mm, mm. Okay. Okay. Want to close the subtitles.
I mean, if you want, you can keep it.
Yeah. Okay. Is my presentation?
Okay.
See? You
Yes,
can see
Yeah,
my
yeah,
presentation?
yeah.
Ah.
Can see.
Okay. I'm going to talk about the structural thermal optical performance stop analysis on ANSI CMAX Optic Studio. ANSI CMAX Optic Studio is a professional software for design, simulation, and analysis of optical systems. Is widely used in industry and research to model how light interacts with lenses, mirror, fiber, detector, and other optical components from simple to high complex systems. Who use CMAX, optical engineers, classical optics, imaging, light designers, automotive, displays, light systems, photonic researchers, companies in aerospace, medical, automotive, and consumer electronic industries. What does CMAX Optics Studio do? CMAX allows you to design optical systems, lenses, telescopes, microscopes, cameras, sensor, projectors, etc. Design from scratch or modify existing optical layouts, simulate light behavior, ray tracing, geometrical optics, Gaussian beam propagation, interference, diffraction, and aberration modeling. Evaluating optical performance, spot size, MTF, modulation, transfer function, waveform error, etc. Optimize the optical system, automatically adjust parameters to improve focus, image quality, or efficiency. Tolerance analysis for mechanical or thermal misalignments. Integrate with other tools. Interface with ANSYS Mechanical, Numerical, MATLAB, SolidWorks, Python, etc. Used for stop analysis cases, structural, thermal, optical, performance. Working modes in CMAX, they have two modes, sequential and non-sequential. Sequential is for right travels through a defined path, step by step, ideal for lenses, cameras, and objectives. In non-sequential, rays can split, reflect, scatter, and follow multiple paths, ideal for illumination system, interferometers, LIDAR, etc. And here's a comparison between sequential and non-sequential mode. Um, Basically, with non-sequential mode, we can simulate better or more complex things like interference, coherence, and other. And usually for match sender interferometers, light guide, and sensor. Even we can convert sequential surface to non-sequential object in CMAX. They have the convert to NSC group, and we can give that transformation. And here is the main topic of my talk. What is stop analysis? STOP is an acronym for structural, thermal, optical performance. It's a methodology used to analyze how structural and thermal factors, including fluids for cooling, that affect the optical performance of a system. In other words, stop analysis allows you to evaluate how temperature, mechanical deformation, or structural stress alter the optical properties of your system. What impact does this variation have on the final performance, such focus, resolution, or big alignment? We show here a study, a case of study of stuff analysis, the Perceval lens systems inside a thermovacuum chamber. The vacuum chamber walls are maintained at a very cold temperature, perhaps to mimic the effects of the other space, while the lens of the system is looking to adjacent room at much higher temperature, possibly emulating a laboratory test. And we have the configuration. But basically, the lens 3, 4, and 5 are getting to very low temperature, about minus 50 degrees Celsius. And the other side, the lens number 1, is about the room temperature that is 25 degrees Celsius. Flowchart of the most significant multiphysics phenomena in a stop analysis. We have heat transfer that this heat transfer can be by thermal stress, can induce thermal stress, and this affect the solid mechanics. That also the solid mechanics can be affected by gravity or external force. This solid mechanics induce a deformation that alters the geometrical optics, and this dark attenuation that is sometimes caused by that attenuation causes heat source and then gives a heat transfer. And also this heat transfer gives origin to a thermal optic dispersion. And here we have the system of the lenses, and we can see here in the blue dot line that is the temperature about minus 50 degrees Celsius, and the room temperature in the red line is 25 degrees. And also we can see all the lens, what are the temperature approximately. Then the right trajectories in the Hette Perceval lens system are plotted and 3 different field angles. We can see here the red, the blue, and the yellow one, the different field angles. And we have here the spot diagram for 3 field angles starting from 0 left. For a low temperature, the minus 50 degrees Celsius. We can see here the spot size, and then how is alternating for different field angles. And then if we maintain the room temperature about 55 degrees Celsius, we can here have the spot diagrams of the 3 field angles start to change. How is stop analysis do in CMAX? In CMAX Studio, you can import structural thermal data or fluid data from FEM, que es finite element methods, analysis software such as ANSYS or SolidWorks. Apply deformation to optical surface via thermal or structural data in non-sequential mode. Use the structural thermal analysis and result start menu to implement the stop analysis to see how these changes affect the system performance. By example, spot size, MTF, or detector image. You can also work with surface deformation fields, SDF, or Cernic coefficients for thermal distortion modeling. And we have here see the star module on CMAX. And in summary, the step 1, you design the optical system, use the CMAX, this is the output file that you're going to have. Then simulate thermal structure. You can use ANSYS or SolidWorks or even COMSOL, and you have a TX or CSV or .dat file. Then you convert to CMAX format using the stop utility or API, and you give a XDF file or .dat file. Therefore, you apply the deformation in CMAX, deform a optical system. In the 5, you analyze the optical performance on CMAX, spot, model transfer function, waveform, etc. And the 6, optional automate, you can use a Sol API that is using scripts or report or batch results to automatize the optical test. And here's a diagram to start in CMAX, the stop analysis, define the system requirements, set up the optical model, select the analysis type. If you're going to analyze the spot diagram or the waveform error or the MTF function, you run the spot diagrams or run the waveform error analysis or run the MTF analysis, and they evaluate the results. Are the results acceptable? If yes, you finalize the design and the stop analysis. If not, you adjust the model performance and repeat another time the Septul optical model. In summary, this workflow is typical in projects where optical design are validated under real-world conditions, such as satellites, space cameras, LiDAR sensor, medical imaging equipment, head-up displays, hoods. And this is the bad about this, that you only can do this in the optical studio enterprise license. That you have, see, all the programs have the same characteristics, but in the star evaluation module only is possible when you use the optical studio enterprise. For the student side, also there is more limited license than the standard license, and you cannot do the star analysis. And also I have seen the problem when I am using the optical CMAX Optic Studio that the help button is not working. I try to solve this. Follow this link that I'm going to share with you, that you can see in the web page of ANSYS, the CMAX Studio help guide, or even you can use the PDF manual. How does compare console multiphysics with CMAX? ANSYS CMAX Optic Studio is more specialized for optic simulation than even console multiphysics. For example, for structural thermal simulation, very detailed, CMAX cannot do that. You need another software for that. For geometrical optical analysis, with ray optics module, you can do in console. In CMAX is more specialized. Graphical optic interface is limited, but in CMAX is high intuitive. Automatic stop analysis, you cannot do that in console multiphysics, but this is available in ANSYS CMAX Optic Studio in the enterprise version. The formation export, you can export the .txt or CSV formats. The formation export, no, you only need to import that in CMAX. Primary purpose, console is for general multiphysics, and ANSYS CMAX Optic Studio is for applied optics. For the future class, we can also follow the tutorials of the flash LiDAR. This is the less complicated LiDAR system. The flash LiDAR is a LiDAR that have no moving parts. For this case, we can compare it to a commercial product. Then you can see this is a diode, and then the diode emits a pulse, and this pulse is captured by a silicium avalanche photodiodes, or even you can do that in a CMOS optic sensor from a photographic camera. How does this work in flash LiDAR? In a flash LiDAR system, the goal is to illuminate entire field of view with a single laser pulse and capture the time of flight. From each illuminated point to spread the laser light, you can use conventional diffraction gratings, split the laser beam into a fixed pattern, like a dot matrix, or passive and efficient but limited in dynamic control. Meta surface or gratings made with meta materials. These are nanostructure surface designed at sub-wavelength scales to modulate phase, amplitude, and direction of light. Can generate complex light patterns from Alexa, silencio. Can generate complex light patterns from a singular emitter or made from materials like silicon, TO, or plasmonic metals. And that's half of my presentation. And here at the beginning, we can see a flash LiDAR system. That is usually the LiDAR that have the
Mhm.
the cars, because the cars are moving, you not need
Okay.
the moving parts.
Mhm. Okay, so David, in this one, you took one case and you presented on it. So you have enough idea now. You can design something, some simple things on the ZMax.
Yeah, yes, I'm going to try to follow the non-sequential mode to do
What problem?
the interferometer. Mhm.
What kind of problem? Interferometer?
Yeah, yes, I don't know how to solve this problem that the license, because you need the enterprise
Mhm.
license, but I only have the student
Yes, but
It
version.
means the lidar system which you are showing here, that Zmax we can do stop analysis using Zmax. So you didn't you have not done that by importing data or whatever.
the lidar example you are giving, David,
Hmm.
the lidar,
Did-
so
Okay, okay.
its data is there.
From the leader,
Yeah.
yes, they are the tutorial. Yes,
Did
yeah,
you try that one? Yeah.
I'm going
The
to
Zmax has.
I'm going to try
Hmm?
that.
Hmm.
I can try that the leader
Okay, it's mean
case.
the Gmax Studio already simulated this thing, and we are just you are trying to simulate this one to learn something so we can apply somewhere else. You
Yes.
did not you did not simulated the lidar system by yourself, like the spot diagram you have showed like this. I'm just asking that.
No, no, I only present a example.
Okay,
Okay.
okay, because I'm very much
Because
interested in.
I am beginner
Mhm.
at the software. I only start to follow the introductory tutorial for CMAX this week.
Okay.
I am simulated only for the sequential case. That is a lens. Uh-huh.
David, actually, the Mudassar, actually, he has expertise in ZMax. So probably if something, some some kind of problem, it can be solved mutually. If you start something, he may guide in some matters.
Yeah, like the lidar system you have showed, like you have showed that we can apply deformation in Zmax, and we can export data, sorry, import data in it, and then we can simulate it. So if you have anything like idea like that, I will surely look at these things you have shown. But I'm very much interested if we can simulate a lidar system, like they already simulated that, but we will see how we can change it and we can do something better than that. So
Mhm.
that is my.
Yes, yes,
So
We can
yes.
see that.
I can try to. I have the SolidWorks software, and also I can
Mhm.
have the ANSYS student version to try to simulate some
Yeah,
deformation and then import to the CMAX. But the problem is that I only have the student version of
same
ANSYS
here.
CMAX.
Yeah,
Yes.
we have also had that limitation. That's why we also simulated interferometers and spectrometer, but we have a limited version. We don't have premium or enterprise version. So there is a so we can design a system which has illumination system like lidar. So I'm also interested in that. If we get something in which we can design the system like lidar system, or apply some deformation, or we can import the data into it of the from the different, and by interfacing, and then we can simulate it. So if you
Yes,
find any way.
I also, because
Mhm,
I am communication and electronic engineer,
mhm,
I taking course on real time operating system. That is going to be the operating system of the leader. When you have the optical system, you need to process the image.
mhm,
Um, we can see here in the in this link. I'm going to show.
mhm.
but this LIDAR project can be done in the student version.
Desde el calendario reunión grupo Gold Láseres.
Sorry.
Empieza dentro de
Alexa,
30
silencio.
minutos.
Yeah, yes, the budget is not very expensive. Is even if you buy a flash leader, there are different types of leader. The flash leader is the less expensive. is because they have no moving parts. The leader, you can even get a leader from
No, I'm saying about the simulation.
We
for
can,
the
yeah, he is saying we can simulate LiDAR and ZMAX using not student version if we have some crack version in which we can do simulation in non-sequential mode, obviously.
So in student version, it's not possible. Huh?
Yeah, so in student version because it has only sequential mode active. In non-sequential, in student
Okay,
mode there is
okay.
no non-sequential. But we have crack one, so that was the old version, but still it worked well. So if there's a possibility, we can design it. It has some system. It doesn't require any mechanical input or something. If it is totally optic based, then we can simulate anything in non-sequential mode. So I'm asking that if the LiDAR system, any LiDAR system which we can simulate, which is mostly an optics based system, so we can try that. If you
Now,
find like flash LiDAR or whatever, I will obviously I will look for this after this meeting. What is this LiDAR and how we can see a simple LiDAR or some
Mudassar,
any kind of LiDAR which is basically optic based.
Mudassar,
Yes.
what I'm saying that this LiDAR can be done in the cracked version.
Uh, yeah, I have to see if it is only a optic based system.
Mm-hmm.
We doesn't need to interface or need to import a data. Then we can simulate it.
Mm-hmm.
Yeah, that
Okay.
is what is I'm saying. So I don't have the exact geometry at the moment in my mind of the LiDAR. So if I have a geometry, then if it is a only optic based system, then we can like it a splitter, grating, whatever. But it is an optical one, except wave plates. So we can do that.
So David, what you are trying to show?
okay, and
No, because our concern at the moment is simulation. So purchasing or
Because,
buying is a different story. So
yeah,
our concern is the simulation at the moment.
that we can have some model or some design. So we
okay.
can simulate it in a ZMAX, or by looking at we can simulate our one as well. That is not a problem. But we have some focus that we want to simulate, so we can work on that.
Yes,
But David, how can you? Because student version you cannot simulate. So how will you do it?
yes. Maybe I can get the help from him from the optical simulation, and then we can also try then to process the data. The LiDAR is like a ultrasonic sensor with laser light, and then when you got the data for that sample, you get the result, and you can implement like a operating system for get the data. This is useful for robotics or for drone or for
Yeah,
another application.
Yeah,
yeah,
definitely it
it's a
is
very
radar.
vast field, but yeah, we are saying because usually or some people here are working on LiDAR, but I didn't see the, you can say I didn't search out for it, or I didn't even see his model how it works. So I will see that. But my concern is if we have some system like a spectrometer, it is a totally optics based, so we can simulate it in a ZMAX. But if we have to put like some motors or something like that which is not optical, so then it will be difficult to simulate it because you cannot put an equivalent every time in the ZMAX. So that's what I'm saying. We have to look for a LiDAR or any kind of system which we can simulate optically. So I am there, I will do it. It will not be a problem. Either it is a sequential mode or a non-sequential mode. In sequential mode, basically we have a variety of analysis. We have a large number of options which we can simulate. So it gives you a lot of data. But in non-sequential mode, we just have a very limited variety like interference pattern, phase pattern, and nothing more than that we can get in non-sequential mode. But still, we can get something from it from that if we simulate in a non-sequential mode. It is basically more near to the real world.
Okay. And then I ask you for help for the license because I have the student license, and I cannot do many things on that.
We don't have license. We have cracked one. We will.
Yes,
We
yes.
are using that.
Well, then you can show me how to do the process. to have
Yeah, but
the program.
surely. Yeah, we will.
Yeah,
do that.
it's a bit kind of tricky,
Yeah.
Okay.
and
Yeah,
but
maybe we can have a meeting one to one to you can help me, or even I can share with the program the computer control.
Yeah,
It's
yeah.
like
yeah.
when the technical install software, they use they control the computer for the other person.
Yeah, we can do that. We will see that when we start working. I will definitely help you. That will not be a problem. You will see that.
Okay. This is the Indian optical company. It's called Hallmark, and this is the price. Is half of the normal price. And
This is
this
the
is, for
interferometer.
example, Michelson interferometer, and they give you also the optical table, and they also have another types of match sender interferometer, another
Yeah.
types. I'm going to show you the link. But I see that it's a good quality. I don't know how you see that.
Yeah, it seems to me a good quality.
Yeah, it's good. It's fine.
Yeah, it's not very complicated. Even you can make it in the lab.
Yeah, actually, we already made
But
it in
you are
an.
planning to purchase it, David?
Yeah, I'm going to try to purchase some of these.
From I
No,
mean,
you
where
can made it in a even very low cost. I will, if you want, we can help you. But you don't need to buy such a expensive thing.
we can
You
help you
can,
to make it in a $500 probably.
yeah, maybe less
Oh,
than that.
okay,
Yes,
Yeah,
okay.
because you know that the Mudassar, he is actually in his university. These kind of setups are there. I mean, they make it like homemade stuff, and it's very
yeah,
very cheap. So if
yeah,
you are really interested, we can help you. I mean, Mudassar can help you.
yeah. Yeah, we just need a source and mirrors, and then at the receiving
And
end, that will be your choice. You want to use camera or something, that will be your choice. But otherwise, that is too expensive for me because we made it here cheaply. So if we have mirrors, I don't know the price, but I think in $300 to $500 we have made this setup very easily. Maybe less than that. I'm just giving you a maximum price because you need basically mirrors, important thing, and a laser source. If you want to use a polarizer, that is again a choice. And then we easily made it at the detector end. That you have to decide you want to use a webcam, because we sometimes I use webcam also. We can use photo detector also. That is totally up to you. So you can, I think you can build your own at very cheap price as compared to this.
Okay. Okay,
Yeah.
this is all from my side. I don't know if you have
even
something more.
even I think Mudassar, I mean, if you can build and you can ship it to the Mexico probably.
Yeah, then it will be
Shipping will be
less than a half
shipping will
price.
be a problem, but otherwise it will be very cheap.
I can buy the components here. You only give me the list.
Okay.
Maybe I can get from United States or from another near
The
country.
parts, you mean the parts?
Yeah, yes, especially where the lenses of the part. Even I see that something from the IFCO University at Spain, they 3D printed the supports of the lenses. You
Yes, yes,
can
it's possible.
I
Yeah.
can design the support and then print in a 3D printer service.
Yeah, David, one
Mhm.
thing, you want to buy this one for where will you do? I mean, where will you do this experiment? It's in the university or in your
No, it's
working place
for me
school?
for have a working place for me.
For your
For then,
personal.
yes, for then I can have more simulation data on CMAX
Mhm.
and then real
Mhm.
verification
So
with the
you
You
do.
can,
experiment.
I will suggest you made yourself, because it will give you a new experience, and it is very easy. You will see, you can, even if it will be economical for you as well, and then you will learn. And because we also have did the simulation like laser interferometers of different kind, and did the experimental stuff of it as well by ourselves. So I think you can made up the spectrometer in your home without any problem. I don't know, optical table maybe you require for yourself. Otherwise, the spectrometer thing is not that much. You can say hard. You don't need to buy
Small
such a.
breadboard. I think small breadboard may be okay.
Yeah, yeah.
Small breadboard.
Usually we made our breadboard here also, so we don't have any problem. But if for that you may need a breadboard, but on that spectrometer, you don't need to buy such expensive if you want it for yourself. You can make it easily by your own hand in your home and with a very cheap price, I think.
Mhm. Yeah, I mean, it's not a very complicated thing.
Yeah.
And if you make by yourself, you can understand more probably.
Okay.
Yes,
Okay.
David?
Yeah,
So,
think about it. It's
yeah.
not just a suggestion for you
Yeah.
that you don't need to buy such expensive system if you can make it in a very cheap price at your home without any help. You don't need any much help. Yeah, just you can do it yourself.
Yeah, probably is
Okay.
possible.
Thank you.
And first thing, actually, I would like, I mean, if you people can start the LIDAR work. And so, David, I mean, if you can seriously involve in this kind of thing, what do you think, David? The simulation.
Yes, my part, I will do.
Mhm. Only
Yeah.
problem will be that you don't have the full version of ZMax, isn't it? So that
Yes.
probably.
Yes, for the
Mudas-
moment, yes.
Yeah, so
Yeah.
Mudassar, probably you
For
can
the
send time
timing,
with.
yeah. For timing, you can check for the data, and you have to check what we want to design. Then we will see how to proceed. First, we need to finalize what we can simulate. Then we will see how to proceed. The version we will see that will not be a problem. Once we decide a system, then we will see how to proceed. I think so.
Kind of little bit literature survey and some
On a
data.
final design,
Yeah.
on page we can design something that we want to make this kind of thing. And simulation, I don't think it will be a take much time if it is possible in ZMAX. I think so.
So, okay, David, this is okay to you?
Okay. It's okay for me.
So, Nabil, where are you, by the way? Nabil. This is the old tactics of the students to. Yeah, Nabil, I think you need to get serious someday.
We cannot hear you. We cannot hear you properly.
Where are you actually?
On my phone, sir.
No, you're. Then open your camera.
Okay, sir. Let me go.
Yeah,
Hello.
I asked you specially. You came 15 minutes late. Okay,
Yes, sir.
and Nabil, and then I mean you came and you didn't show that you are here. So did you listen?
Where, sir? Yes, sir.
What?
I attended all the meetings.
But why I'm hearing the echo? I mean your net is not proper. What is that?
No, sir.
Sometimes they have
Fine.
create problem.
This one, the airports.
Yes.
Mhm. Did
Yes,
you
sir.
listen, Nabil? Did you listen the discussion and talk?
Yes, sir. I checked it. I listened to all the things about the lead.
ये घर पे हो कहाँ पे?
Government.
Asking you in Urdu actually. घर पे हो कहाँ पे?
Government.
But anyway, your net is not okay probably.
Yeah, we cannot hear you. So
Yeah, I mean this Nabil, you have to solve this
Sir,
problem. In every meeting, it's like this.
connected on Wi-Fi and internet both. So I don't know.
You have to increase the bandwidth of your net at home. I don't know what exactly the problem.
Sir, actually, the port works fine. I don't know why it's not working today.
don't use
Okay.
the airport. Sometimes airport is not working correctly. That's why there's some noises. If you use
Maybe,
without,
maybe I'm sitting in front of circular, so that could be the reason.
Okay, so did you listen the discussion, DDR kind of thing?
Yes, sir. I listen. Yes, sir.
So I mean, how about if you also involved in this one? Because now you don't have anything to do.
Actually, we can. Yes, sir. I don't have anything on pipeline. Actually, what this is, we have to go through the stuff first. If it suits, we can go through.
Yeah, with
it's very it's very difficult for me at least to understand what is
Yeah.
what is he
No,
saying.
his voice is not properly. Actually, I cannot hear you properly, Nabil.
We can talk about this
Okay, you
later.
turn off your
Maybe.
camera. Turn off your camera and then try to speak. Turn off your camera. Yes, now.
Can you hear me now?
Not properly, yaar. I don't know what is the
Am I
problem.
audible?
We
Am I
can
audible?
hear, but not properly. I don't know.
Yeah, there's some problem.
You don't have a, I mean, use the headphone kind of thing with the cable or something.
I'll search
His net is very low. I can see from here his net connection is very low. That why is the problem.
Ah,
So,
okay.
so you can
So,
mute yourself. We will see later.
okay, so the thing is that, I mean, Mudassar and David, at the moment, I think you people better to start this later. And David will be doing some preliminary kind of thing. Yes, David? I cannot hear you. Your
Okay.
mic. Yeah.
Ah,
And
okay.
yeah, so Mudassar actually has a quite enough expertise in ZMAX. Okay. So he can solve many problems actually. And the other one, Nabil, is also having, but he's, I mean, kind of careless somehow. And but anyway, Mr. Fiaz is not here, who was also supposed to collaborate. I mean, he's interested to collaborate in something, but he's not here today. And Zanfar also, I mean, some problem with his computer exactly on time. So he went to the repair shop. So I don't know. So Nabil is always, I mean, we have to expect this thing from the Nabil most of the time.
Yeah.
He's a special guy.
Yeah.
So
Dr. Fayad was saying something that day. Is that one is already in work in process, or we are just going to start it?
who started?
No. I'm saying the Dr. Fayaz last time when I said a group, he was saying something specs about laser diode. This work is already started, or we have to start something like
No,
that?
Mudassar, I will tell you, nothing is started.
Okay.
Nothing
No,
is
I'm just
started.
saying if
No,
it is in the
no.
in between, so I can join and from there I can continue.
No, because there
Okay.
is no proper discussion yet. What
Okay.
exactly he wants.
Okay, that's
Just
what I'm saying.
randomly some message exchanges and this kind of things. So it
That's
cannot
why.
be cannot be started in this way. I mean, it has to be proper.
Yeah,
I mean,
that's why I did
yeah.
not comment on that day
Yeah.
much, because I do not know what he want and what he want to design. So once
Yeah.
he tells us, I will see how to deal with that.
Yeah, I
That's
mean,
why I'm
so
just making sure.
yeah, that is why, I
everything
mean,
is all-
he was supposed to be today, but he didn't come up. So that may be, I mean, maybe if he comes in the next meeting. But at the moment, this David's idea can be started. So that can be a good. And in this way, David will also learn the ZMAX probably.
Also, before we can start to the flash leader, we can simulate the lens. Maybe it's more easy to simulate that lens. The problem I keep that from COMSOL Multiphysics is a tutorial. They also give you the files, but it's in COMSOL. We need to do it in CMAX. Okay.
Okay, so
But
I will see that.
yeah, so do you have a COMSOL licensed version, David?
No, I
No.
don't have the console.
Mhm.
And maybe I don't have enough space because it's very big, about 20 gigabytes of information, that program.
Okay. So probably if there is nothing to discuss more, so we can conclude this meeting.
Yeah.
And if you want to add something, David, or something like this.
No. Also, we can, for another meeting, see from Python simulation for optics.
No, first we have to start one thing, and then we see. I mean,
Okay.
much better if we. Put,
you can give me another task.
Yeah, I will give you. I'm thinking about you yet.
Okay.
But meanwhile, you can start this one with Mudassar.
Okay. Thank you.
And because Emacs is very handy kind of tool. And if you can have a grip on it, you can do many things. These are the advantage of the Zmax.
Yes, and because the CMAX is now part of the ANSYS company,
Yeah.
you can extend for many other applications
Yes,
like
many
the
other applications can also be easily now implemented in this way.
Yeah. The Python kind of simulation like ZOSP, I have seen couple of paper. They use ZOSP module. I don't know what is this. I was also interested, but we will see that later once we start from the LiDAR system. Then we will see how to do that in Python. I'm also interested
think-
in that, but
Yeah.
that is a little bit different thing. So we will see that later.
And Python, actually, I think it can be linked with the Zmax, isn't it?
I don't know exactly, but there is a SOSP module. I don't know whether they link with the Zmax or they do some Zmax kind of 3D plot, 3D layout and 1-2 simulation graph by using that module. I don't think they.
I
Mhm.
think that
Yeah.
is used Python in CMAX for the automatization of the optical testing. You can use the Python scripts for automatization lenses or
It's kind of
another.
add-on for the Zmax.
Yes,
It's
they
possible.
have. Yeah,
Uh-huh.
they have Mathematica, MATLAB, Python, and even API. That is
Mhm.
when
Mhm.
computer
Mhm.
programs connects with another service.
Mhm. Mhm. Okay.
Okay, so it's mean you are working on a Zmax, you can connect it with the Python at the same time and they will transfer the data between these two.
I don't know if you can share data, but I think that you can execute some scripts on the CMAX.
Mhm.
Okay.
Yeah, that one they have
But
some script.
internally.
Yeah, internally they cannot communicate with the Zmax one. They just have script.
I have no idea about that, but I'm going to search for that. For
Yeah,
give
I
you
have.
a
I also don't know. I just have an idea that they work on a Python. I still don't know whether they just write a script in a Python and they did that work, or they just communicate with the Zmax. But I don't think it is possible to communicate with the Zmax through like interface something. So I will
Yes,
see that.
I'm going to search about that, but
Yeah.
even you can communicate with Excel
Mhm.
from Microsoft with Python or on other programs that they
Mhm.
have internal process and that you can share data even with the Arduino board or another microcontroller. They
Yeah, we
have
will see.
because they is the operating system Windows, they have
Mhm.
internal process that can share data between programs. But I'm
Yeah,
going
we will
to
see that.
search more about that for have a, a good answers
Yeah,
because I don't
let me
know
know.
at the moment.
Let me know if you have find something like one in the
Mhm.
Zmax and one in the Python, and you can communicate at the same time with the both. I'm much more interested in that because it will give you a variety. In Python, you can define anything in script. Zmax still has some limitations, like you cannot define non-linear stuff in it. So you have to see this kind of thing through Python. So I'm much more interested in that as well. We will see if there's a possibility in future.
Okay, I'm going to search for that.
Okay,
Yeah.
and the second thing, actually, at the last, what I want to mention that the website, if you have seen, in the website there is a tab you can see that virtual lab. So
Mhm.
for the virtual lab, what I am planning to do actually, that I will do it, that to remotely the some experiment can be done. In the beginning, I mean, with some lasers, you change the parameters, you set the parameters of it could be an oscillator, amplifier, grating, and then you can
Yeah.
acquire the data. So it can be done remotely.
Yeah, like
Acquire
virtual
the
lab.
data, and then you apply that you want to do this experiment, okay,
Mm.
and you gave the permission, and then you can perform the experiment virtually.
Yeah,
So
I
this is
understand.
what I want to do on my
Uh, uh,
website. That yeah,
I do a quick search and they say that it's possible to communicate with
yes,
Python
okay,
and CMAX. They have
okay,
an app API. App,
okay,
Okay.
okay.
okay, API.
We will try that. Then we will see if this is possible. Then I have a lot of ideas, but we need to see something which we can introduce non-linear characteristic in the Zmax at some point. Then we can do a lot of things. But there's a problem of non-linearity in Zmax. We cannot reduce that part. We will see that if that is
Yeah, so
possible.
David
Then
can
I will
David
try.
can go through and see these kind of things,
Yeah,
and
yeah, he
some
will
kind of
see then.
survey. along with his project. And we have 5 minutes. I think it's almost 4 minutes now. So Nabil, do you want to say something before to conclude? Nabil, do you want to say something?
His mic is off.
No. Your mic?
Okay, sir. Can you hear me now?
Yeah.
Am I audible properly?
No. Same. Try to fix next time. Yeah. Now it's gonna finish the
Don't
time.
don't use the AirPod. Just use your laptop. Then it will fine. I like me in AirPod.
I think his net is very slow, probably, or
Yeah, that can be a reason as well.
Actually, he's right. Maybe it's due to the AirPods.
yes. Now it's a little
Actually, I
better.
use it. Yeah. So I'll try to use some headphones or something.
Yeah, but your net is, I think, it's kind of still it's a kind of the problem actually. So try to fix this one, yeah, next time. So probably we are.
It's very unstable.
Yeah, usually your university net is much better than the anyway, but home net can also be. It depends. So I mean,
Actually,
yeah. Okay. Anyway, I will conclude this meeting now.
4G, I don't know why it's not working.
No, we cannot hear you properly. So this meeting will also be, I will upload on the website, the recording of this meeting. So probably whoever want to listen what happened in the meeting, they can. So, okay, thank you very much, Mudassar and David and Nabil.
Thank you, sir.
And I hope that David and Mudassar, they may collaborate now to start something. Yes, David?
I'm interested. But let's see.
Sure.
Yes, yeah.
My pleasure.
Yeah, that would be very good for both of you and for my platform as well. So we'll see what will be the next meeting. Okay. But this discussion will be there, LIDAR related kind of thing. Okay. So let's signing out now. Thank you very much. Allah Hafiz.
Thank you.
Bye.
Bye, David.
Bye.
See you soon.
See you.